No, he was like, this is that's all happened. I know. Things they're like, oh, yeah, she told me. Yeah, guys.
What do you think? What? And so.
That's coming from that. I'm working.
No, it's oh yeah, no, I don't. I feel no problems. 2 weeks.
Yeah, they're reversing. You're not. Say.
I think it's
Yeah.
there's no way. There's
Hi, Rosie. Okay.
Okay, let's start off with this. So this is you're gonna have a problem like this where you're gonna have to sketch a derivative graph. No, sorry. Given the derivative graph, f prime graph, sketch the function graph, sketch the second derivative graph, and also be able to indicate all the intervals as well. So let's start with this one, and then we'll do the optimization problem on the back, and then we'll just continue to pick out problems from your quiz review. So go ahead and start with this. Start with your sign lines. So build your f prime, build your f double prime.
On the endpoint, is that mean like you don't post it how you calculate it?
Well, yeah. So your sign lines will go from one endpoint to the next. So yeah, you're gonna have. But are you asking if? No, you're only testing between the two endpoints, right? So there's no need to test a 6. There's no need to test a -5. Okay, so for your f prime sign line, you're picking off your x-intercepts, and then you're just looking to see is your graph above or below your x-axis, and that's going to indicate the slope behavior of your original graph. For f double prime sign line, you're picking off the max and mins, the peaks and valleys. Those will be the points of inflections of your original graph. And then to determine your concave up, concave down off of your f double prime, off of your f prime graph, look at the slope. So if my f prime is indicating a negative slope, I know my original graph is going to be displaying concave down. Positive slope means concave up. It's going to keep alternating. So A through G, you're going to practice writing out all of your intervals. This should feel easy because you're just reading off your sign lines, but also practice writing out all your because statements as well. And then students tend to forget that relative min, relative max, and POI also has because statements. We'll do the graphing at the end. Any questions about the sign lines? I think this is the most important part of the problem, being able to get this correct. I'm going to highlight the ones that students typically have more trouble with. Not the identifying of the min and max at POI, the because statements tend to be left out. And then if you just say that because sign changes, that's not close enough. That's not clear enough. You have to indicate what is changing, right? So name the function that is changing signs. Otherwise, that's not a valid or a clear justification. Okay, as you sketch your f of x graph, you're just going to follow the rise and fall of the graph of your f prime sign line. Don't look at your derivative graph. Though this will just throw you off. Look at your f prime sign line. And then there's also some additional details for your when you sketch your graph. We have anchor points, so you know you're going to start here and end here. And then you can worry about this at the end. Once you sketch your graph, you just want to make sure that your lowest y value is a -7 and your highest y value is a 5. And if you just sketch your graph lightly, and if you realize that it's not quite there, you can always push and pull on your graph to get it to fit into that box. Is everyone okay? A through G? Okay, I'm going to take this off and start doing the f prime graph, or sorry, f of x graph. Okay, so I want my graph to rise until it hits some value at -3, where the graph is going to flatten out for a moment, but it's going to continue rising until it hits a relative max at -1. And it's going to go all the way down to some minimum at 3. And it's going to go up to this final point. So rise, rise, fall, and rise again. Now, this is the path of the graph. Your concavity is not going to change the path. Okay. So I'm looking at my range from -7 to 5. So maybe I can just make this a -7. But I need this point to be higher so that this can go up to 5. So maybe I can adjust it to go up here and come down. So I basically have my sketch, but I want to pronounce the curvature of my graph a little bit more clearly. So I'm going to just wherever my graph lands, I'm going to just highlight -3, -2, 1, and 4, because those will be where my graph is going to experience a curve change. So from dot to dot, I'm going to make my graph visibly change its curvature. So I'm going to start with concave down. Then from this dot to next dot, I'll do concave up. -2 to 1, make it concave down. 1 to 4, concave up. 4 to 5, concave down. Okay, everyone okay with your f of x graph using both the sign line? The sign line will get you your path. Your concavity will update it with the proper curvature. Okay, your F double prime graph, you're just going to rely on their second derivative sign line. Okay, so now these will be the x-intercepts on your F double prime sign line. And you're just threading between these points. This tells you you're going to start below, then you'll be above the x-axis, then below, then above, then below. And the shape is not going to match what you would expect. So don't worry about the shape. Just have the graph go through these points. Okay, everybody comfortable with this type of problem? You'll see, basically it'd be a different graph, but the steps are all the same on tomorrow's quiz. Okay, next page. Let's try our optimization problem. Okay, I'll leave this up here for another moment if anyone's still needing to look at it. Okay, does anybody still need this? Cost is related to surface area. They're going to be optimizing surface area / cost. Volume is your supporting equation. Eventually, this volume information is going to help you get your surface area or your cost equation down to one variable. So here, how many surfaces are we going to be that we need to account for? 6. Yeah. So there's a closed box. We have the base and top are going to be the same, and then the sides will have their own unique cost. So you're just adding up the area of each of your rectangular surfaces. I have 3x squared below. I have 3x squared above. For my vertical faces, I have one face that's xh. And if I have an xh on one side, I got an xh on the other side. If I have a 3xh on one side, I have a 3xh on the other side. So you should have 6 rectangular areas that you're going to be putting together. Top and bottom is the more expensive material. And then the sides have a cheaper cost. Now we can update this and call this the cost equation. So if I add up these like terms, 3 plus 3 is 6, 7, 8, 8xh times 6. Okay, any questions building out your surface area, your volume, or incorporating the cost? So now we do want to find the derivative, but not yet. We just want to get that h out of the way. So use your volume equation to get that h replaced in terms of x. And then you can get this ready for power rule, then find the derivative, then find a critical point. For my second expression, the x's do cancel out. There's an x left over in the denominator, but I'm pushing it up to the top to get it ready for power rule. Any questions up to this point? So now I'll find C prime. And set equal to 0, and then algebraically try to find a way to solve for x. once you solve for X, you're pretty close to you're pretty near the end of the problem. You just have to go back and reread the problem and be able to provide what they're asking for. Are they asking for the cost? Are they asking for the length? Are they asking for the width? Are they asking for the dimensions or the height? But once you solve for X, anything you're looking for has already been established. You don't have, there's no more new formulas that you have to create. Whatever formula you need is already that you've already built them from previous. So it's asking for the cost. So I can just put into one of my cost equations. It's asking for my dimensions. So I have my width. I just have to find my length and my height. And then we have a formula for height. If you search for it, you'll find it. There's a formula that you've already built for height. Okay, so everything you need is already been done. You just have to search for those equations and plug in, and provide what the problem is asking for. So the problem is asking for the dimensions. Sorry, this problem didn't ask for the cost, but if it did ask for the cost, let's just practice at getting that cost information as well. And then any of the cost equations can work. I mean, there's 4 variations of it, but you just want to pick the one that you think is the most efficient to plug in. Yeah.
When you're using X to plug it back into like Y, would you use the rounded version like 1.882 or would you use the whole unrounded version?
I'll accept either. All right, so these are the 2 extended problems on your quiz. The other ones will be smaller problems like EBT, Rolle's mean value theorem, first derivative test for concavity. So let's go back to any questions here?
Do you always want us round in 3 decimals or is 2?
3 is the preferred because on the AP exam, they're going to ask for 3. So yeah, do 3 decimal places. All right, so going back to your quiz review, I think we did first 2 pages here. Right, number 12.
Yeah.
Is the actual quiz gonna look like this?
It's more like one of that plus plus like the first page.
Okay.
Yeah. Okay, try 12 and 13. So if you can create a slope sine line, then you can just pull that information from your slope sine line. So for 13, where f prime is negative and decreasing, so f prime negative, that means, well, first of all, this is the original function graph. So f prime negative means we want negative slope and where the slope is decreasing. So where my graph is experiencing concave down as well. So I want decreasing and concave down. So point A is the better fit, even though there are 2 points that looks like, first off, this is not, that looks like more of a point of inflection. So that doesn't quite look like concave down. This is concave down to concave up. So this is not as clear, but this one is clearly concave down. So we want negative slope and concave down. That's going to be option choice A. All right, 14. 14, if you can find your slope and concavity sine line, then you're able to pick the correct options. So for 14, go ahead and all these are involving information that you can pull from your concavity and your slope sine line. So find your f prime sine line going through first derivative test, get your second derivative sine line using your test for concavity. And then once you have your sine lines drawn out, then you should be able to narrow down your options.
For the optimization problem, are we gonna get the diagram of the box or will we have to draw it?
You have to draw it. Yeah. But yeah, if you're having trouble drawing the box, if you just draw them like this first, and then just connect your corners. Yeah. But if you're having trouble, I can draw it for you too on the quiz. Okay, try 14. Okay, so from my sine lines, I can see I have 2 points of inflection. I have one relative extrema, one relative minimum. All right, try 15. 15 is Rolle's theorem. Rolle's theorem is basically mean valley theorem, so it's the same formula. Remember, there's two conditions for mean valley theorem and Rolle's theorem. So you want to make sure you practice stating out your continuity statement, your differentiable statement, and then here's a formula for mean valley theorem and Rolle's. So mean valley theorem and Rolle's uses the same formula, but there's a restriction with Rolle's theorem, and it's the fact that this slope between the endpoints has to turn out to be what? Zero. Yeah. So once you can confirm that, then you can set, you basically are looking for a critical point. Once you get that to be zero, you're just setting f prime equal to zero. But mean valley theorem, this can be zero, but it could also be any other rational number. All right, so try that. See if you can work through your process for Rolle's theorem. So I confirmed that my endpoint produces order pairs that will give me a slope zero. So this will we can continue forward with Rolle's theorem. We know that our slope between endpoints is zero, so we're basically just going to ask the derivative to find that slope zero on the curve. let's do a second derivative test practice problem. I did this in the morning review this morning, but if you guys can just get onto the sheet of paper and copy this problem down.
Just like that. You guys are cute.
I know, it's not.
It's like there's It's essentially, well, that's more like.
I was right. That's only 5 tries, bro. No. It's right. No, it's 1 try. The reason why it works, stomach. Are you sure? Yeah, it's fine. Wait, all you know.
Finding critical poles.
Okay, so second derivative test is you're finding the same result as first derivative test. You're trying to find max and min, but you're going down a different path. So find f prime first, then find the critical points from f prime. But once you find your critical points from f prime, you're not going to go through the sign line. You're going to plug those points into the second derivative function, and then using the concavity information, then decide whether those critical points from f prime is a relative max or relative min, depending on the concavity. Okay, so f prime, find your critical points. So these are your candidates. If we wanted to go through a first derivative test, you would just create your sign lines, but we're not going to do the sign line. We're going to find the second derivative function and plug these values into the second derivative function. So when I do direct substitution into second derivative function, I get 18. What can we conclude with that number there? Concave up, right? That 18 just indicates positive value. If my second derivative is indicating that this critical point has a concave up behavior, that means we must be looking at a what? Relative min, yeah. All right, second derivative or plugging -2 in. Here I'm getting a -18. The number is not that important. It's the fact that it's what? It's negative. So a negative value for my second derivative function means what? Concave down, and the concave down shape indicates we must be looking at a relative. Yeah. So the trouble spot that students experience is they see that positive number and they want to associate that with max. If they see negative number, they want to associate that with min. So just be aware that that's where the most common mistakes come from. Okay, let's do an extreme value theorem here. These are the problems that I did this morning in the help session. So
So just no offense.
what's the only condition that we need for extreme value theorem? Discontinuous, yeah.
Job sure.
Once you find your critical points, confirm that whether you want to keep them or to whether we want to include them in our candidate list or whether we want to remove it. So -1 and 2 are both of these valid ones for us to test. What do you guys think? Yes. Okay, so the way we tell is we look at our endpoints and to see, do our critical points land outside or inside the interval? If it's outside the interval, then we don't want to test it. We only want to test what's inside the interval and the endpoints. Okay. Use your calculator to find the y values. And I just want you to tell me the y values. Lowest y value is your absolute min, highest is your absolute max. Okay, and then finally, try this one. This is a mean value theorem problem here, number 2. How many conditions are there for mean value theorem? 2 conditions, yeah. So practice writing them out. Okay, this is the formula you'll be using for mean value theorem.
This is.
So, yeah, your continuity statement, you have your differential statement. You find your endpoints, find the slope to the endpoints. Okay, so do this portion first, then find the derivative, set them equal to each other, solve for x. And then your c-value has to live between the endpoints. So if it's on the endpoint, it's not part of the solution set. So our c-value has to be between the two endpoints. All right, sorry for your quiz tomorrow. Bring your calculator. I'll send out a reminder this afternoon.
The value if it's greater than 3, what's about it?
Then it's, if it's equal to 0, it's like, then it's a conclusion. So we have to go through a different process to find it's a relative maximum. So you'll probably go through it first. Yeah.
No.
Have a great day, guys. See you tomorrow. Study for your quiz. Thank you. Have a good day. Bye. See ya.
Thanks, Mr. Green.
Nice talk.
You know who I am? I'm Mr. Green.
Huh?
And then one of my friends is Mr. Green.
Bye. Thank you. Bye.
So fast. The test grades in this class, my quiz grades are really good. Mr. Yang, did you get a haircut?
We already got these, right?
Oh, you did? Okay, sorry. Yeah, then you're good. Yeah, I think I already got it, and maybe I think I know it on the class.
I'll check and make sure that I have.
Yeah, thanks.
Morning, Mr. Yang.
Morning, how are you? Oh, sorry, I have a class set packet.
Did you take that off? On accident. It keeps falling off. It's so. Wait, Hannah, can you put me up there, please? Thank you. You guys have. On this side. Pick it up.
I didn't imagine. Body.
Yeah.
And like I work on the behavior, like it's like the things.
My bag.
I knew it was Friday on the Like, I make on steak from State Farm, so I love that. Yeah. I love it.
You're all on an alpine site.
Yeah.
That's always so long. So like that.
What?
I do. This is,